Thanks for joining us for part 2 of our weather series, Weather Changes, What's Next? Last week we talked about our wintry weather and really a lack of wintry weather over the past several weeks and months and why the La Nina pattern and various oscillations prevented much of snow accumulation over the past couple of months in addition to very warm temperatures. Now we want to look forward over the course of the next several weeks and months heading into spring and summer. And of course, when we talk about spring and summer weather, that often means thunderstorms, and in some cases, of course, that could mean severe thunderstorms. With that in mind, we do have Severe Weather Safety Week in Ohio that runs from March 20th through the 26th. And whenever we talk about severe thunderstorm and tornado warnings, we always tell you to have a way to get warnings, and that's so you can make a plan to be safe. And two very good ways of doing that include getting a NOAA weather radio and, of course, our Storm Authority weather app. Those two features will allow you to get those severe thunderstorm and tornado warnings instantaneously, so you know what to do to prepare and how you can keep yourself and your family safe. The best place, of course, in the case of severe thunderstorm and tornado warnings is indoors in a sturdy building on the lowest level of your house or in any building you happen to be in, and, of course, in an interior room. Now, when we're talking about thunderstorms and severe weather, perhaps an underappreciated aspect of what we deal with when thunderstorms do develop is lightning. And that's because lightning is one of the top weather killers in the United States. Every year, 50 deaths and hundreds of injuries take place as a result of lightning. Of course, most victims are in open areas or near a tree. Lightning strikes the United States 25 million times per year, so of course it's very common. The surface of a lightning strike, it's 5 times hotter than the surface of the sun in the brief instant where it appears, and updraft winds and thunderstorms lead to the difference in electric charges, and that, of course, leads to lightning. And when we see those thunderstorms, that's what causes it. Now, of course, when we talk about lightning, unfortunately, one thing we have to talk about are lightning deaths. And lightning deaths disproportionately occur in activities that involve lots of time outdoors. So fishing, beach going, camping, farming, boating, they're all upwards of 17 deaths per year as a result of lightning. Also, construction workers, roofers, and golfers, they're all at risk from lightning strikes. Interestingly, and perhaps less well known, is that 80% of lightning deaths can be attributed to men, and that's because historically, men are more likely to be more frequently involved in the activities that are listed on your screen. So we talk about lightning deaths. Next up, we have lightning and thunder, and lightning and thunder, of course, are interrelated. For every 5 seconds that pass between a flash of lightning and when you hear thunder, that's 1 mile of distance between your location and where lightning strikes. So also the speed of the thunder is influenced by the temperature where it occurs. So at 40 degrees, thunder travels at 747 miles per hour and covers 1 mile in 4.82 seconds. At 80 degrees, thunder travels at 776 miles per hour and it covers 1 mile in 4.64 seconds. So they're very close, and a good rule of thumb is to count seconds. If you see a flash of lightning and hear thunder 10 seconds later, the lightning strike is roughly 2 miles away. Another point is that the sound dissipates as it travels away from the lightning bolt. So we often hear people reference heat lightning, but all heat lightning really is just lightning that's too far away from us to be heard and more easily seen after dark. So the impacts from lightning, that's important to discuss. It's important to remember that lightning is attracted to tall objects. It's safer to be inside, but it's a good idea to remember to stay away from windows. And the best advice for swimmers in the backyard, in the pool, is that you want to head inside as soon as a thunderstorm is close enough that you can hear thunder. Now, lightning can strike many miles away from any thunderstorm cloud associated with it. So remember the saying, when thunder roars, head indoors. Now, the next item I want to talk about is something called convection initiation. So one of the pitfalls of forecasting rain and thunderstorms in the warmer season, in the spring and summer, is that certain subtleties can make a major difference between multiple rounds of thunderstorms and a sunny and dry day. Part of the fuel for thunderstorms is driven by the sun. Because air is a poor conductor of heat, the sun heats the ground first, and that causes warm updrafts to form. In order for thunderstorms to develop, there needs to be instability. Instability is associated with temperatures decreasing with height in the atmosphere. As those temperatures fall with height, air continues to rise. But if the updraft hits a layer of warmer air, it will not be able to form towering cumulonimbus clouds, which are associated with thunderstorms, and this is referred to as a capped atmospheric profile. In this kind of setup, it makes our weather high and dry. Conversely, if there is enough heating or if there is a geographic location where the warm air cap is thin or weak, the cap can be broken, allowing strong thunderstorms to form. Now, many times the difference between a capped and uncapped atmosphere is a matter of only a handful of degrees high in the atmosphere, so that makes it relatively challenging to predict. Now, in addition to thunder and lightning, another feature of thunderstorms in the spring and summer is often hail. Now, I want to point out that hail is different than sleet, which occurs in wintry precipitation setups. Hail is a result of thunderstorm updrafts blowing raindrops back into the cloud where temperatures are below freezing. The raindrop falls and it's blown back into the cloud several times until its weight overcomes the strength of the updraft. The stronger the updraft, the larger the hailstone. And of course, large hail can cause extensive damage, and it's dangerous to people, animals, and plants. Now, on your screen, it's an example of hail sizes often used by television and National Weather Service meteorologists, as well as trained observers. While marble, pea, and penny-sized hail generally don't cause too much damage, anything quarter-sized, roughly 1 inch in diameter or larger is considered to be severe-sized hail and would warrant a severe thunderstorm warning from the National Weather Service. Golf ball-sized hail or larger is relatively rare in this part of the country. It's more common, though, in the Great Plains and Mountain West, where the air's freezing altitude is relatively lower on average. Next up is a microburst. Now, a microburst is kind of an interesting phenomenon. It's a localized column of sinking air within a thunderstorm. They're usually less than 2 miles across. Microbursts can cause extensive damage, and in some instances, they can be life-threatening. In the case of microbursts, small water droplets and hailstones become suspended in the updraft. Sometimes an updraft becomes so strong that it holds a large amount of these droplets in the upper portion of the thunderstorm. Evaporative cooling weakens the updraft, making it unable to hold the large amount of rain and hail in it, so it falls to the ground and spreads out in all directions. The location where the microburst first reaches the ground experiences the highest winds and the greatest damage. In certain setups, wind speeds and microbursts can reach up to 150 miles per hour. Now, here in Ohio, they're relatively rare, but occasionally they do happen. Next up, we want to talk about tornadoes. Of course, tornadoes have occurred in every month of the year. Spring and early summer are when tornadoes are most likely to occur here in the Buckeye State, as wind shear driven by large temperature gradients helps to fuel their development. The most tornado-prone month of an 80-year period of record is in June, but as we can see on the screen here, there's a second maximum of occurrences that happens in the fall season. While winter twisters are rare, they aren't unheard of. In fact, winter tornadoes can become more common in future years due to the climate shifts and an overall warmer environment. We want to take a look at this case here. On December 11th of 2021, an EF1 tornado touched down just outside of Ada shortly after 3 in the morning. The tornado had wind speeds over 100 miles per hour, and it caused extensive damage to a barn and a few nearby structures. Luckily, the tornado missed the populated part of the village, but it's a good reminder that severe storms are possible at any time of the year. Coming up, we're going to have much more about tornadoes and severe weather, and meteorologist Nathan Kitchens is in next with an interview with the National Weather Service.
In our last segment, Adam Musyt discussed the climatology of tornadoes across Ohio, and we do typically see that maximum in tornado activity from May through July that actually accounts for over half of our recorded tornadoes since 1950, and we average just under 20 tornadoes per year across the state. But it's also important, as Adam Musyt discussed, that tornadoes can occur in any month as long as conditions come together, as they have been recorded in every month of the year across Ohio. And we typically see the weaker side of tornadoes, typically over 90%, or the EF2 or weaker, which can still cause loss of life and can cause damage. But we are also not immune to those larger violent tornadoes. We are approaching the 4-year anniversary of a major tornado outbreak that left its mark right here on West Central Ohio. Residents of Salina will never forget Memorial Day of 2019. On that night, a fierce EF3 twister with winds of 150 miles per hour completely destroyed 43 homes and damaged over 100 of homes in Salina. The tornado was just one of nearly 24 that struck the state, with a rare EF4 striking just outside of Dayton. For the Mercer County EMA director, it's his job to prepare for weather disasters.
Preparations are ongoing. That's what our job mostly is. We do plans. We speak to the public when we can, how to prepare themselves at home, how to have a plan for severe weather, whether it be a tornado, a storm, a snowstorm, a blizzard, anything like that, flooding. Have that plan both at work, at home, at school.
Those plans were put into action on the night of May 27th. One life was lost in Salina when a vehicle was lofted in the air and thrown into a home. The EMA worked with area fire departments and EMS to comb through the wreckage left behind.
By daylight, everything had been searched at least twice, all the damaged buildings. But then, of course, the Ohio EMA is asking us for damage assessment right away. So as soon as daybreak got, we were out there doing damage assessment, got that into the state, and actually got a federal declaration for that, which brings FEMA in, which is a lot of work too, but they come with a large checkbook, and they do help individuals and families.
For Robbins, Salina is home, and the damage was extensive throughout his hometown.
We actually at least moderately damaged 100 homes. And I was born and raised here, so I am talking to, people that I know very well. Are the head nurse at our local emergency department at Mercer Health. Her home was destroyed, So when I go around and do that damage assessment, sometimes it makes it hard. But still, you have to let those people tell you those stories too.
While tornadoes grab all the attention, it is important to be ready for any weather disaster, and Robbins has seen it all throughout his tenure.
That is probably the most catastrophic and very looking, but we've had some very heavy flooding. 2003, we had a lot of flooding here, and that impacted well over 100 homes at that time. Now, those homes usually weren't destroyed, but they did do a lot of damage. And, we've had the ice storm that did a lot of public damage to electric power wires, a lot of roof damage and damage to homes, and a lot of wrecks. That was 2005, I believe. So, we have had several presidential declarations, and they all impact different people. But, if it's your home, your business that's impacted, that's going to be the most important one to you.
And while tornadoes tend to grab all the headlines, especially on YouTube and social media, when we look at weather disasters over the last 30 years, heat was the #1 weather killer. But you see what is next on the list, and it's something that we get often here in Ohio, and it is flooding. So we need to be aware of flooding and also lightning, winter storms. Here in Ohio, we can get it all. And it's important to be ready for when these weather disasters take place, because it's not a matter of if, it's really just a matter of when here in the Midwest. So are you weather ready? You want to make sure you have at least 2 ways to get weather alerts, whether it be a tornado warning or a severe thunderstorm warning. Do you have multiple methods to get those alerts to you? Also, do you have a plan in place? Because you want to make a plan. Identify where that safe place is, either in your home or in your place of work. Communicate that plan with your family, and you want to make sure you have emergency items either in that safe place or near that safe place, whether it be flashlights, non-perishable foods, or a blanket to have at hand when that weather warning is issued. So we talked about being weather ready, and you can't be weather ready without knowing the difference from a weather watch to a weather warning. So a watch means that we have conditions in the atmosphere favorable for severe weather. We can go on with our day-to-day activities, but keep an extra eye on the forecast when a watch is issued. Now, the warning, on the other hand, means take action. So again, the warning means that severe weather is imminent or occurring, and that is the time to seek shelter and go to that safe location. Your smartphone can actually be your first line of defense when it comes to getting these weather alerts. Most of you watching likely have a smartphone, and if you have an iPhone, for example, you can just go to settings, go to notifications, and go down to government alerts and make sure those emergency alerts are turned on. And that is one way you can get either severe thunderstorm, tornado, or flood alerts sent directly to you. But also the Your News Now weather app is another avenue on that smartphone to get those weather alerts. You can get those notifications. Just make sure those notifications are enabled on the app. Go to the notification settings and make sure the sounds are turned on, so you will receive a sound when a warning is issued if it's in the middle of the night, so it'll wake you up. Also, look at interactive radar on our weather app to see where the storm is. You can also check out our latest video forecast on the app as well. let's talk about how to be severe weather ready in your home. So where to go, you have that plan now. So when it comes to that plan, make sure it's an interior room in the lowest level of your home, away from windows and doors. You want to make sure you cover your head with a blanket to protect yourself from falling debris. And obviously, this should be a no-brainer here, but you want to stay away from electronics during a severe weather event. So when it comes to your home, let's talk about where you go. So the more walls between you and the outdoors as possible, obviously, is what we recommend. You want to stay away from any outdoor windows and outside walls, and that lowest location in your home as well. So in this case, it could be a hallway, it could be an interior bathroom, or even a bathtub. You know, when we look at tornadoes that strike, oftentimes we will find that the bathtub is the only thing left for many homes. So a bathtub, if that is an interior bathroom, that is a great place to go in your home. But if you have a basement, that's actually the #1 place that we recommend. Getting as low as you can go in your basement, that is the best place. If you have one, again, that's going to be your place to take shelter during a severe thunderstorm. But again, it's not just about your home. When you're driving, you need to make sure you're weather aware as well. So we recommend staying off the road if there is imminent severe weather. But if you have to get out, or if you find yourself just caught in the middle of it, you want to make sure you have ways and kind of have a plan of what you're going to do. So if there is a tornado warning, you want to go to the nearest safe location. But we know a lot of times that may not be an option. You might be out in the middle of nowhere and there is no safe structure to seek shelter. And in that case, the best advice is to pull over to the shoulder with your seatbelt on, duck your head down low, cover your head with either a coat or blanket or any items that you may have to protect yourself in your vehicle. And again, you don't want to get outside your vehicle, especially when it comes to overpasses. Oftentimes people mistake overpasses for a safe spot to seek shelter during a storm, but the matter of fact is when you're under a overpass, you actually become a stationary target for flying debris to hit you. And oftentimes those winds are actually accelerated, so the winds even get stronger because they are pushed in that narrow space underneath the overpass. So the bottom line is never use an overpass as your shelter during a tornado warning if you are out on the road. So we talked about tornado safety, how to get those weather alerts to you. Meteorologist Prince is going to discuss the tools we use and how we can forecast severe weather and possible severe weather days in advance.
Welcome back, everybody. I am meteorologist Prince, and for this final part of our weather series, we're going to look how we both forecast severe weather before as well as during severe weather events that occur in Western Ohio. First, let's go over what constitutes a severe storm. So first, we could have damaging winds, and the criteria for damaging winds are 58 miles per hour or greater. Significant criteria is 75 mile per hour winds or greater. Then we could have large hail, which we could have 1 inch diameter or larger. That's the minimum criteria. Significant criteria is 2 inch diameters or larger. And finally, we have tornadoes, of course, and any severe criteria for tornado is radar indicated rotation or confirmed tornadoes on the ground. Significant severe criteria for tornadoes when we have EF2 or stronger tornadoes. So let's go over how each severe weather mode forms. So let's start with damaging winds. First, we need a thunderstorm, and in the mid-levels, we need dry air to be in train. What then happens is that the moisture evaporates, and then the atmosphere then cools in response, and that starts to begin a process where the cooled air becomes dense and is feeling the effects of gravity. As it does so, it begins to accelerate down to the earth. The air hits the ground, spreads outward, and this is where we have widespread straight line wind damage across Western Ohio. Next, let's go to large hail. So first we need a thunderstorm again, and this time we're going to go way into the storm, into the mid to upper level. So we need a strong updraft to suspend a condensation nucleus for water droplets to deposit on to form hail. So then we have the water droplets go above the freezing level and they become super cooled. Once they hit the hailstone, they freeze and form layers of ice. Eventually the hailstone will become so heavy that the weight exceeds the force of the updraft, and the hailstone then crashes down to the surface and falls as large hail here in the area, and possibly some very large hail up to the size of softballs possible. And finally, let's go over how tornadoes form. So we need strong surface winds, and then we need even stronger upper level winds above the surface. What happens is we get then a horizontal tube that begins to rotate, but we need this tube to go into the vertical mode. So this is where the thunderstorm updraft becomes handy and then tilts the column of rotating air into the vertical, and then any additional wind shear will just enhance this tube of rotating air, and then eventually a wall cloud will begin to form with this rotation, and as more humid air is being ingested, that's why the wall cloud forms, and finally this process continues until the vortex reaches all the way to the ground, and if it reaches the ground, we have a tornado on our hands. Now let's go over the ingredients needed for severe weather in the form of wind shear, lift, instability, and moisture. So first, we need a very strong upper level trough coming in from the west with a lot of cold air with it. This will then form an area of low pressure ahead of the trough and begin to bring up moisture and instability from the south. As the storm then tracks to our east-northeast, the warm front goes north and brings all that warm and moist air into the area, so that brings moisture and instability. With this cold air battleground with the warm air, this then begins to help really crank those low level winds, and when that intersects with a jet stream that comes out out of a different direction, that's wind shear, and finally with the cold front, that will initiate lift for storms. So this is an idealized environment for severe weather and tornadoes. Finally, as that cold front moves eastward, the cold and dry air will come in and end any severe weather threat. Now let's look at how we forecast severe weather across the area with the QT diagram. So first, let's go over a few important parts. So the height is shown in the horizontal black lines in the form of pressure. So a higher number, 1,000 millibars, for example, is closer to the ground than 850 millibars. Next, let's look at these three lines in here. The dark red dashed line is the air partial temperature. The solid red line is the actual air temperature or environmental temperature. And finally, the green line is your dew point temperature in the atmosphere. Next, let's look at these wind barbs in the middle part of your screen, and this shows both wind speed and wind direction with height, helps us analyze possible wind shear. And then finally, over to your right, we have this system where we plot the wind shear and the wind direction and speeds. This is called the hodograph, and where we have this hodograph, we use a vector system to determine both not only how much rotation could a storm have, but storm mode as well. So let's begin to analyze this chart a little bit more. Notice how we have two little indentations of the green line that's far away from the solid red line. Those are two areas of mid-level dry air, and as the storm entrains that dry air, it'll help begin to cool the storm, and then we have damaging winds that fall to the surface. Next, look right here at the bottom of your screen where this green line is really close to solid red line. That is low-level moisture needed for thunderstorm formation. And then notice how we have this shaded area from the surface to the top. This is convective available potential energy, or noted as instability. Next, we have to look at the hill growth zone, which is determined between the -10-degree isotherm line and the -30 isotherm line. And notice how where the cape intersects this zone, that's where we could have large hail. In this case, the shape of the profile of the cape is relatively skinny, so that should mitigate the hailstone threat a little bit because the updrafts will be weaker. Finally, let's look at the wind shear, and this storm has a lot of wind shear with it. So south-southwest winds then turn to southwest winds intensify. As you go further up, west-southwest winds even stronger, and then the winds are screaming out of the west as you get above about 500 millibars in height with the atmosphere. Finally, we plot all this data using the hodograph, and notice how we have a lot of low-level turning. This is very favorable for development of tornadoes. But notice how the hodograph then becomes more unidirectional or a straight line aloft. This is telling me that we could have a squall line to form with embedded supercells that could produce damaging winds and tornadoes. And this event certainly did produce two strong tornadoes in the area on November 5th of 2017. Finally, let's look over radar technology of how we go and track severe storms as they form. So we'll start on the tornado side. So this event occurred in June of 2021, and notice how we have this supercell here, and there's this hook echo on the southwest side. Notice how we have this indentation in the hook echo. That is warm, moist air being ingested into the storm and helping to tilt that updraft into the vertical. Next, we can look at the velocity scans, and remember, greens go toward the radar and reds go toward away. Applying that logic, we could deduce that the radar is located to our northwest. And notice how the greens and reds are really touching just west of the state line in Mercer County. This is where we have winds rapidly changing directions with height, and this is where a rotational couplet is in a tornado vortex signature. Finally, we look at correlation coefficient, and remember the high values which depict hydrometeors of the same size and shape, and the pinks, and then the blues is where we have a lot of different sizes up in the atmosphere. Notice how we have this blue ball right here just west of Mercer County. This is a confirmed tornado on the ground producing damage, and we use these signatures to determine from the radar side if we have a tornado on the ground lifting debris in the air. Next, let's look at how we detect damaging winds. So notice that this is Fort Wayne, Indiana. We have this backward C shape right here. This is telling me that we have a lot of winds coming into the storm, and that's being brought down to the surface in the form of a rear inflow notch. And notice how we go to velocity, we have a lot of bright reds and oranges away from the radar depicting very strong winds. As a matter of fact, we had winds of 98 miles per hour in Fort Wayne and several wind gusts of hurricane force in our area June of 2022 from this event. Finally, let's look at large hail. This occurred in May 28th of 2017. So this is western Defiance County. Notice all the purples and pinks here. A lot of power being returned to the radar here, indicative of large hail. And we apply the algorithm, we have hail possibly up to the size of 2 inches in diameter. And notice how we then tilt the radar in the vertical. We have whites and pinks here capable of hail aloft, and notice how there's not much underneath it. That is the updraft, and this is telling me that we have a hail core above the storm capable of producing large hail at the surface. Finally, this is an interesting little feature we note. Notice how we have this spike here along I-69 Indiana. That is a 3-body scatter spike, and that's hail reflecting the radar beam at multiple areas. And we look at correlation coefficient, we can actually see that the hail is falling right here, but notice how that spike continues well down to the south. So there are a lot of tools that we use to determine severe weather mode and threat across the area to help keep you and everyone safe. Thank you guys so much for watching.